Okay, so let's jump into our assignment. Make this text a little bigger here. Big enough? All right. So, um, what was the assignment to create the checker? Like, did somebody win Flippy Dealy?
Yep.
All right. So I gave you a starting point. We're not fully bouncing back to online GDB. We're just temporarily focusing on the back end of our thing. And then pretty quickly here, we're going to be taking this code, embedding it into our Unity project, and then hooking an interface up to this to make it match. So we're kind of going through the whole software development life cycle for creating this. So we're not moving away from Unity. We're just temporarily playing in this sandbox. Okay. So let's just quickly walk through this just to make sure I remember what it does. So, and then we'll start writing the stuff for it. Um, all right. So in main, we're creating our game manager. We're telling it to play. What's a game manager? Game manager maintains a Connect 4 board. So it creates one of those. Let's go and look at a Connect 4 board real quick. A Connect 4 board is a two-dimensional array of checkers with 6 rows and 7 columns. So when I build an instance of the board, I'm setting that equal to a two-dimensional array, rows and columns of checkers. I then have a function for the thing to display itself. It's just displaying the checkers, and I'm getting the color from the checker, and get color just returns the first letter in caps. So R is red is R, and black is a B. So it writes it out so you get a grid of those outputs. So inside of, and then a checker is just the color. You create it with the color, it has a get color. So checkers are pretty simple, at least in the current state. So what does play do? Play creates a random number, well, creates a tool for generating random numbers. Then it creates a tool for, or a collection of the colors, the two different colors R and B, for whose turn it is. And then I have it just currently making 10 random moves in order to start filling out the board with stuff so we can kind of see it grow. So I display the board, then I try to make a move. We had written this last time where I give it a random column to drop the checker into 0 through 6. And the color, I is going from 0 to 1 to 2 to 3 to 4. So when I take the current value of I and I mod it by 2, I'm going to get a 0 or a 1, and that's going to alternate back and forth between red or black. So 0 mod 2 is 0. That's going to be red. 1 mod 2 is 2 goes into 1 0 times with a remainder of 1. That's going to be the B. 2 mod 2, 2 goes into 2 1 time with a remainder of 0. That's going to be an R. So it keeps bouncing back and forth using this little mod 2 trick thing here. Um, and we're going to keep trying to make a move without increasing I until we make sure we get a legal move. Since I'm randomly generating columns, it's possible that across 10 turns, I just keep filling up the same column and end up with a technically illegal move. So that's what this little do while thing is for here. Try to make a move once. If it doesn't work out, try again. Make a new random number. All right. So then it goes on, it's on the board. After we make that move successfully, then we check, is there a winner? And notice what we're passing into this is our move result, which we talked about last time. That's kind of our the thing that we're using to check this. So our move result, we talked about last time. What if I have a function that needs to return more than one value? Well, we can build our own value type. This is kind of where object-oriented programming gets really good. You know, we can invent an object type that holds the exact kind of information that we need to hold instead of just returning a Boolean like we originally had it. So our move result holds on to the success of the last move, which we expect by the time we use it, it's always going to be a true. The row we moved into, the column we moved into, and the color that was made for that move. When we first build a move result, it's unsuccessful. It has two illegal rows and columns are both illegal, and there's no color, so kind of just like an empty canvas, if you will, for this guy. But then we have a ability to build a move result with the four pieces of information set. So that's what move result currently is. So your assignment would have been to take this move result and try to determine a winner based on the current contents of this, since we know that if somebody just won, it will be as a result of the last move that they made, which is represented inside of move result. Good. Well, you're passing an instance of move result, which holds all those pieces of information. So here's is winner right here. This is where we're calling is winner. Well, you're going to see it unfold today. Okay, so result is our variable name that is of type move result. Result gets filled up right here on line 25, and it's going to get filled up with four pieces of information. These four pieces of information, which is going to give us the stuff we need to know to detect a winner around that move that was just made. Because we know if we just made a move and there's a winner now, that move involved that checker that we just placed. All right, so really the assignment is to detect a winner related to our last move that was made. So this is like a little bag that holds these four pieces of information, and we're throwing that bag into our is winner check, where we can now extract information. We currently can't extract information, although I made it all public, I think, to make it mimic a struct. I think you had mentioned last time. Um, let's call that good enough. So we can access those things without having to build getters, since we made them public, and then we just won't make changes to it. So game manager is going to keep up to 10 times, make a move, check if there's a winner. Right now, obviously my is winner for my board, this guy right here, always returns false. Doesn't do any actual checking, just says, nope, not a winner. So we might run into situations here where we did create a winner, but we're not currently detecting it. That's what we're writing for our assignment, is this piece that takes our move result and decides if that move was related to a winning move. Good. You're passing it an instance of move result, which is filled up with those four things. Okay. Well, I mean, we'll see it today. So there must have been something you were doing that made it not work that way. But as it's written here, our is winner is taking in an instance of move result, and we see right here move result contains these things. So that's how we're going to work with this. All right, so if we just run this real quick, we should see 10 moves with our thing. So here was I guess our first empty one. Then this was our first checker. This was our next one. This was our next one. This was the next one here, so on and so forth. Do we ever actually get a winner on this board? Nope. Okay, so it's possible in order for us to check this, we'll have to generate more turns. In fact, maybe just keep generating turns until there's a winner. But we'll burn that bridge when we get to it. All right, so just to give us our example, I don't remember what the last move that was made here is, but let's just assume it's this guy right here. Let's assume that was actually, we know that's not the last one. This guy? Okay. Yeah, thanks. Okay, so this is the last move we made. It doesn't really matter what the very last move is, but for us to come up with the algorithm for this, we want to take into consideration what this move is, which will be, I should have numbered these guys are rows and columns. What this this will be 0, 1, 2, 3, 4, 5. So column 5, row 5 is the move with a red checker. So what we want to do is we want our is winner to go to this place and look at all the possible ways you potentially could win from that location. All right. So that means we can possibly have a vertical where we check, this guy counts as one already. This could be 2, 3, and 4. So we can go up to 3 spaces up. We can't go any space down. So really our vertical check, which we can do that first. We can do the horizontal check. It's going to go both directions for where we currently are, but it's only going to be able to go as far as it possibly can go based on where we are on the board. All right, so let's think about vertical check here first. All right, so let me open up here. Steal that. Actually, just steal the whole. So let's design is winner. All right. So let's give ourselves actually a starting. Well, it doesn't matter, I guess. We'll go ahead and put an R right there. All right. So we want to start off by looking for a vertical winner. Okay. So vertical winner is going to take our current position and we're going to try to go up as far as we can, counting the number of checkers in a row that match our letter. Right. So let's start with that. Yeah, so that's true. We don't actually have to go up because there shouldn't be anything above you, right? So we would only go down in this move. Um, yeah, so for vertical winners, we only need to check down from us. And if we can count 4 things in a row, which we obviously aren't going to get here, then we know we have a winner. So for vertical, check down from our last move. Oop, ninja. All right, so let's go write that part first. We're trying to find if we have a vertical winner. So we'll go into is winner here inside of our Connect 4 board. Minimize that. So here's win. So let's look for vertical win. Vertical check. Look at last move and see how many checkers below us in a row match our color. Right? That's what we're doing there. Okay. So we already know the column we're in, that guy. So what we're looking at is the row, and we're going to go down from that row. So we're going to need a for loop that takes I on a journey between the current row where the move was made. That'll obviously be a 1 count, right? And then go 1 column below that, or rather 1 row below that, and keep trucking until we either run out of runway or we find a checker whose color doesn't match the starting point. All right. So let's go ahead. We have our starting point checker, which is right here. That's result. So our starting point color, let's extract those couple of things. So we're going to say string winning color is equal to result dot, do we just call it color? Yep, result dot color. And we made it public so we can just directly access it. All right, so we'll just give ourselves a little local variable there that allows us to keep track of what we're actually doing there. We didn't have to store it in a variable. It was already stored inside of the struct, the object, but we'll extract it out here. All right, then we're going to say int start row is equal to result.row. That's this piece right here. And then let's create a int vertical count. And we'll start it off at 1. We know that they at least have 1 in a row based on the last move, right? All right. So that means for start row, it'll actually be result.row plus 1. We're starting 1 row below, right? 1 row below where we made that last move because we've already counted the move we made. All right. So we want to take I on a voyage between start row and the last legal row, which will be rows minus 1. So let's write a little for loop that does that. So for int I is equal to start row, keep going as long as I is less than this dot, call it rows, hopefully. Okay. This dot rows, and then I plus plus. All right, so this is potentially going to take I on a voyage from start row all the way to the very bottom of the board, unless we bust out before that, right? So under what circumstances do we break out? Well, one circumstance is if we run into a checker that has a color different than our winning color. That's one possible thing. Now, my winning colors, well, we'll do it as strings. Okay. Because I think that's what I'm storing it as, right? Is a string? Yeah. Okay. So we'll first ask the question. Do the color of the checkers match? Because remember, our Connect 4 board holds on to a checker array. So the thing at bucket row column is going to be an instance of checker. And we want to be able to ask that instance of checker, what is your color? And I think we already have get color from that guy, right? All right. So we'll check this first. Lost. All right. Do the colors match? So if this dot, the board at row I, comma, start column is equal to, okay, I'll fix it here in a second. Thank you. Column is equal to result dot call. Did I call it column? All right. So if it's equal to result dot column, then we'll keep track of where we are. So we want to look at our board at bucket I, bucket result or start column. If that checker has a color, so what we have right here is a checker. Okay. Past what? Result.column directly. Yeah, you can. I just already was doing a thing where we're extracting our individual variables just so we can have good variable names as we're doing our logic. All right, so the board at bucket I dot column, I comma column, if that guy has a color that matches our start color. So this is a dot get color. We want to know C sharp. I don't know if C sharp's double equal sign lets you compare strings or not. So there's probably a get. Hide this. C sharp, compare strings. There's probably a dot equals or something like that. But it's using double equal sign. I think we use string dot equals. We use string dot equals. Okay, good. Well, oh, it's string dot equals. It's a class method.
Yeah.
Okay, so then just for clarity here, let me do this. I'm going to say checker, cur checker is equal to the checker at that position. I know I'm writing a lot of variables, but let's just keep it clear. So that I'll say string cur checker color is equal to cur checker dot get color. Then right here, we want to ask the question if string dot it equal like that, capital E equals, if string dot equals, and we want to compare our winning color to our cur checker color. So if we find a match, then we want to increment our vertical count, right? Vertical count plus plus. So if we find a match, increment it. Now, if we don't find a match, then we've gone as far as we can go. Else, we have gone as far as we can go. So break out of the loop to check if we got 4 in a row. So get at least 4 in a row, even though presumably we would have checked it the previous time if it wasn't 4 in a row. So we will break. All right. So that's one thing that might get us out of this loop. Another thing that might get us out of this loop is that we run off the end of the rows, right? So with that in mind, do we actually have to put an if statement in there for that? Or does the loop already handle that logic for us? This loop is going to start off at start row, and it's going to keep going as long as we are looking at a row that's less than the total number of rows. So it's going to bail us out. You know, we might only get to check 2 rows, or in our example here, we're not even going to get to check any rows, right? By the example we were looking at over here, if I start right here, notice that we started off with start row being whatever the row we started with plus 1. So that means we're actually looking at our start row right here. Let me make this guy red. Is that guy right there, which is off the board, right? So this is row 0, 1, 2, 3, 4, 5. So if our moves had a row of 5, we're going to have our start row be a row of 6. Is 6 less than 6? It's not. So this loop is going to go through 0 times this particular check, right? Remember, for loops and while loops are pre-check loops. We check the Boolean expression before the body of the loop runs at least even 1 time. All right. Whereas a do while loop, which we used at wherever over in Game Manager, that guy runs at least once before we ask any questions. All right. So in our example here, this loop isn't even going to run 1 time. But in plenty other examples, if we're looking at let's say the move we just made is this guy. Move we just made is this guy, then our start row would be that guy right there. We still got some runway to go with. So that loop will go through 1 time, 2 times. We'll hit the end of it. We'll bail out. We'll see that we only got a count of 3, didn't have a winner. We haven't asked that question yet, but that's the deal here. All right. So this loop either naturally ends where we've checked as far as we possibly could ever check, or we short circuit it because we ran into a color that's different than the color we were looking for a winner. All right. So any way you cut it, we can ask the question if, so we can say, was there a vertical winner? So we'll ask the question if vertical count is greater than or equal to 4, return true. We had a winner, right? All right. So that's for checking vertical winners. Questions about that? Good. Right here, we break. Right here, we return true. So this method will end as soon as, remember, return makes a method immediately end. So we will stop there. All right. So now let's check for horizontal winners. The next easy one, right? All right. So for horizontal winners, now we can go left or right, because we aren't necessarily at the bottom of the or at the top of the pyramid, as it were, from our previous move. We purposely only had to check things below us for the vertical win because we know we're at the top of that column. All right. So now let's check horizontal winners. Let's say check left direction first. We actually could, in fact, what we probably want to do is we probably want to go as far left as we can until we see a checker that doesn't match our color, or we run to the side of the board. Then go as far right as we can until we find a checker that doesn't match us, or we run to the edge of the board, incrementing the number of checkers in a row we found each time. And then as long as it's something greater than or equal to 4, we know we have a winner. So we'll just go both directions. So let's check left first. We know we're going to have a, well, let's just call it int horizontal count. We'll start off at 1 for ourselves. All right. So now we want to have a loop that goes from the column we started at towards column 0, stopping either once we bypass column 0 or we hit a checker that's a different color. All right. So we'll have a for loop for int I is equal to, we're going to start off at our start column minus 1. Start column minus 1. That is, we're going to start, if this is the checker we just put in there, our start column minus 1 will be that guy right there. When we go to the other direction, it'll be start column plus 1, which will be that guy right there. And then we'll go all the way to that end. All right. So we'll start off at start column. I'm lost. Start column minus 1. Notice that we've already counted ourselves. We already gave ourselves one number for the move we made. All right, start column minus 1. Keep going as long as I is greater than or equal to 0. Right? We're going to keep going as far as we can to the left until we either hit the far left column or we short circuit out of this guy with a break because we ran into a checker that's a different color. Each time through, we'll subtract 1 from I. All right. So then we're going to ask a very similar question here. Here, I'm just going to steal. We're inside the for loop. That's a local variable. That for loop, we'll just steal all that. So we'll get our current checker. Probably could have made that a single variable up top, but move on with life. So we'll get our current checker at the current row, which was start row. and the column we're currently interested in, which is I. So we'll get that checker. We'll get that checker's color. We'll ask the question if the winning color is the same as that checker's color, then we're going to say horizontal count plus plus, else break. We are looking at a different color, so we have gone as far left as we can. All right, make some sense? Good.
Start row, result row plus.
Start row, result row plus one, start row.
So like,
Yeah. So we want to actually see start row minus one, or just say result dot row. Result dot row might actually be cleaner than adding one there and then subtracting one. They mean the same thing, but good catch. I'm lost. All right, so we can say result dot row. That's the row we started with. Let the column move on us to go from whatever column we are just to the left of our start column all the way towards the left, possibly breaking out early. Then we want to go to the right. So we're going to have a very similar for loop. So we're going to start off at start column plus one, keep going as long as I is less than this dot columns. Incrementing I each time. So now we're going to the right. We'll get the current checker we're interested in. We'll get its color. We'll ask, is it the same as our winning color? If it is, we'll just keep adding on to our horizontal count. So at the same count that we possibly picked up some going to the left, we're now potentially picking up some going to the right. Keep going until we either hit the end all the way to the right, or we find a different color checker. When all is said and done right here, we break out of this, horizontal count should be the total number of same color checkers in a row that match the winning color and involve the most recent move. That's what this guy is doing, right? I'll kick it down the line here and throw out. So we'll ask the question, if horizontal count is greater than or equal to 4, then we have a winner on that side. So we'll return true. We have a horizontal winner. All right. Questions on determining the horizontal winner? Now, we could actually pause here for a second, and we can up our number of things, and let's see if it accurately detects vertical and horizontal winners. Could have also just done that for vertical winners, but I think the two checks we've done so far are the most straightforward checks, right? Horizontals when things get a little, or the diagonal rather, is when things get a little sketch. It's going to be very similar to what we did for horizontal though. But we're going to be moving rows and columns. So let's check these guys first. All right, so back in our game manager, I'm currently just hard coding in 10 moves. Now we want to keep moving as long as there's not a winner. All right, now we know that we're going to have to make at least one move to start the game. So when we say play, we can do this as a do while loop. So we're going to say make moves until there is a winner. I think there is a such thing in Connect 4 where you run out of total moves and the board, somebody wins, right? Or nobody wins, right? There's like a tie. Okay, so let's just for right now hope that we don't get that in our little testing, but we will have to put in a special case for once the total number of moves have been made. In fact, hey, we can just throw that in there. We know max moves will be rows times columns. That's the maximum total moves that could ever be made, right? That's inside of our board. I'm gonna forget about it for right now. Let's just focus on testing the couple of things we're testing. So we definitely want to make one move. So we'll display the board. We will make our move until we get a legal move, which should be real quick on that first move. Then we ask if there's a winner. If there is a winner, we'll say console.writeLine, console.writeLine. We have a winner. We don't have to worry about saying which color or anything right now. And if we have a winner, then we're going to break out of this. We're done making moves. And then we will probably want to show the board one more time. Showing the winning state of the board. All right. And we're going to keep doing this while what is true? While there is not a winner. All right. So we're actually going to use the same logic right here. We want to keep going while there is not a winner. So we'll actually move we have a winner outside of this while loop. We can get rid of, well, actually I could just leave that on there. Get rid of that if statement because this is effectively doing the same thing as that if statement. Our loop will die as soon as there actually is a winner. And once this loop is over, we know there's a winner and we'll show the final state of the board where we should see either a vertical or a horizontal winner. All right. So let's test this guy. Oh, did I have I did that on purpose, I'm sure. Oh, I'm still waiting for my first bug in my code. I put them in, did I? Where? Into the while loop. That's this guy. Line 34, blah, blah, blah. Oh, thank you. No, that's not it. This should be a semicolon. Yeah, do while loops require a semicolon at the end of the while. It's part of the syntax. Does not exist. 25. Oh, here's my, we lost our variable I from our for loop. So we're going to say int cur color is equal to 0. We'll say cur color. And then each time through our loop here, we'll say cur color plus plus to add 1 to it. So we keep bouncing back and forth between the colors. And then line 33. Oh, so while result isn't in there, we actually set result here. So we're just going to move that before the while loop because its scope is not part of the do while. Fatal exception. Oh. So we are checking potentially a whole bunch of checkers that don't exist, right? So our entire logic, I think our logic's in pretty good shape. But as we go to the left, right? As we go to, for example, as we go to the left, especially after that first move, we're real quick running into null pointers, correct? So in our check, we need to make sure before we ask the color of a checker, we need to make sure it is a checker. So let's go back into our Connect 4 board. We need to do this on the, we don't actually need to do this on the vertical. We know there's checkers below us, right? For the same reason we don't have to check above us for the vertical. But for the horizontal, let's make move. Where is winner? Okay, here's this winner. For the horizontal, before we get this checker, we need to make sure it's actually a checker. And if it's not, we want to go ahead and bail out of this loop. So we can just ask the question, if that guy is something, well, we can just say if he's equal to null, break. Are we looking at a real checker? Or is this a place where a move has not occurred? We're going to be doing something very, very, very similar. We go to the right. So before we start messing with the checker we're currently trying to work with, let's make sure it's a checker. Otherwise, we're going to get out of this loop. All right. Do we? Yeah, we got a winner. So here's our vertical winner there for black. Let's see if we can get a horizontal. Ah, we got a horizontal winner right here. Horizontal winner. Where's my winner? Oh, no. Am I just not seeing it? Oh, reds. Yeah, here, horizontal. Okay, so we've exhaustively tested this. It must work for every vertical and horizontal thing. All right, so now we have those winning types set up. So now we got to look at the diagonal, right? All right, so we'll go back into our Connect 4 board. Now check for diagonal winners. And really, this is going to be very, very, very similar to what we just did for our horizontal, except we're going to be moving rows and columns each time through when we go to the right or we go to the left. So I'm going to actually start off. Except we need to go left and up. We need to go left and down. We need to go right and down. We need to go right and up. But we only want to combine the numbers when we go up and left or down and right, and then compare it to left and down or right and up. Those are going to be two separate counts. All right. So let's just steal that code. All of it. Okay, so now check diagonal winners. So we're going to say diagonal up, left, down, right count. Get some very interesting variables here because we want to keep track of this, right? Okay, so as we're doing that, our columns are going to move just like before, but so are our rows. So when we go to the left and up, our columns will move, will shrink, and our rows are going to, let's see, So it'd be 0 at the top, subtract, right? Rows will subtract. So we'll say int I is equal to start column minus 1, since our diagonal count is already 1. And just say j is equal to start row, and I'm going minus 1. Each time through, I will go minus minus. J will go, I also said minus minus, right? Because the rows are going to be going up this way. And since we start at bucket 0 here for row, we'll show the picture here. If this is my current row for my move, this is the row we want to look at next. Then this row. This is the column we want to look at next. Column we want to look at next. So we subtract 1 from the column, we subtract 1 from the row. We subtract 1 from the column, we subtract 1 from the row. So on and so forth, right? All right. Now, here's something new that we're doing here. You may not have done this, and I'll actually have to see if this is, I might need to throw int in front of this guy to make that accurate. I'm not familiar enough with C# to know if that's required, so we'll just wait for it to scream at us. But this is a for loop syntax that came from old school C, where we can actually, I mean, up to this point, we've always used for loops to count on a single number, right? But we can actually count on as many numbers as we want, rather than having to create, local variables that might, mess things up. So this one for loop is going to have an I and a J. We probably could have called them column and row if we wanted to, but we didn't, and I and J becomes way more confusing. So, that makes it fun. So I, J, K are the typical throwaway variables that are in computer science are used for loops. Once you get past I, J, K, now you're in a 4-dimensional array, which is completely possible, but it's not a very common occurrence. All right. I think it's what Iron Man used when he was doing his Tesseract stuff. Oh, that's pretty bad. All right, so we'll start off at our start column -1, so it'll be to the left. We'll start off at our start row -1. So the very first place, if this was our starting point, the very first place we're going to look is right here. Column -1, row -1. All right, and we're going to start counting. I see we're just about out of time.
Yeah. Also, do you have to check for J being greater than 0 as well?
We do. Yeah. So we need to enhance our Boolean expression because we want to make sure we don't go off the left side or go off the top. So this is a there's that. So right now we're saying I is greater than or equal to 0 and J is greater than or equal to 0. So we're making a complex Boolean expression. I would probably wrap this in parentheses just for sanity's sake. Wasn't required, but both of these conditions need to be true until we're done counting. So we bail out as soon as one of our rows or columns is in a bad place. All right. I'm going to go ahead and just throw some asterisks here and here. So we have some nice errors in our code for Wednesday. All right, so we'll come back Wednesday. We'll finish writing this diagonal. Then we're going to start incorporating it into our Unity project. Hopefully you see where this is going with the diagonal. It's basically the same as the horizontal. We just have to do it twice. I won't give you assignment over Easter break. So well, I can give you one if you want. All right. Okay. But let's well, I mean, I'll let you know what the next assignment will be. Something like that. All right. So we'll come back on Wednesday because we don't have class Friday, correct? All right. So I'll see everybody on Wednesday. I will post actually I'll post on Slack the link to the code currently. Even though it doesn't currently run, if you want to just comment out that diagonal part, it'll run.
Professor,
Yep, that's,
I made a mistake on this. I did this all in Unity because I just,
that's fine.
okay, that's.
You gave me a link to your code. It's fine.
Oh, I was.
Yeah, I don't care where you do it. I just gave you a starting point with online GDB. So, yep,